From the probability of a customer to use credit card case, we have tried to construct the tree diagram. And from the T diagram, we got the joint probability of credit card use. We then construct the probability of each random variables and define it in a table, which if we make it as a graph, this is how the probability distribution would appear. So in short, what we have done before was getting this binomial probability distribution from the credit card used by customer by first constructing a tree diagram. Fortunately, we do not have to construct a probability tree each time we want to construct a binomial distribution. We can instead use the following formula for calculating probability associated with a binomial random variable. So, for a binomial random variable x, the probability of x successes in n Bernoulli trial is given in this formula. For x, where our x is equal to 0, 1, 2, and so on until n, the number of outcomes possible. Or n can also be the numbers of trials. By definition, the factorial of 0 is equal to 1. And also, we have the formula for expected value, variance, and standard deviation for a binomial probability distribution is given as follows. For average is n times p, n is the number of trials, and p is the probability of success event. And for the variance is n times p times q, where q is the fail events, probability of the failure event. And the standard deviation is just the square root of the variance. Now let us get back to the credit card use case we used before. And I would like to show you, rather than constructing the tree diagram to get the probability of outcome, let's just use this formula. For example, I would like to know the probability where 2 customer out of 3 uses credit card. And based on the case, we know that the number of trial is 3, yeah? So n equals to 3. So we have here, just plug in the number into the formula. The n is 3 factorial divided by 2 factorial, 3 minus 2 factorial, times the p probability of success was 0.85, powered by x is 2, and okay, this is supposed to be n, yeah, not 1. So 0.85 powered by 2 times the failure probability 0.15 n, 3 minus 2. And using your calculator, you will get your n result is equal to 0.325. This result that we got using formula is just similar with the result that we got when we construct the table from the tree diagram. When x equal to 2, the probability is 0.3252, just similar with the one that we got using formula. Let's diagram again. If we want to know if none of the customer used credit card, so using the formula, it's just 3 factorial divided by 0 factorial, 3 minus 0 factorial. The p is 0.85 powered by x is 0 times 0.15 powered by 3 minus 0. And using your calculator, you will get a result 0.003375, which is just equivalent to 0.0034, just like what we got before. Now you have learned about binomial probability and calculating events which follow the binomial probability distribution. There is still one more discrete probability distribution that you will learn, that is the Poisson distribution. We will discuss it on our next session. So, see you later on the next video.